Imagine a late afternoon in the pouring rain. The downpour roars, the streets are crammed with umbrellas, everyone hunches over and rushes along, clothes splattered, shoes soaked through, but you walk calmly in the middle of it all. No umbrella, no raincoat, even dressed in a light-colored suit. In your hand is only a palm-sized device, looking no different from an ordinary laser pointer. You press a button zap, an invisible beam shoots out. Strangely enough, right above your head, a dry zone opens up. The rain vanishes before it even touches the ground, as if dissolving into thin air. Bystanders gape in shock. Some whip out their phones to record, others cry out, "What on earth is that? Some kind of high-tech umbrella? Or a leaked military weapon?" Still, you keep walking leisurely, letting all the curious stares trail behind. Around you, the whole world is drenched, yet you remain completely dry, as if the entire storm has been programmed to avoid only you. Sounds like a scene straight out of a sci-fi movie, doesn't it? A laser umbrella against the rain, no covering, no bulk, just one button to turn the sky itself into your personal roof. But wait, could this idea actually work in real life? Or is it just a futuristic illusion that sounds plausible, but falls apart under the scrutiny of science? And if someone really built it, would you dare live under such a laser dome? So what's the principle behind a laser umbrella? The idea sounds simple enough. As a raindrop falls, a laser would strike it, delivering an intense burst of energy that instantly vaporizes the droplet before it ever reaches you. In other words, instead of letting the rain soak your clothes, you'd be using technology to erase every drop of water on its way down. If achievable, this would be one of the coolest anti-rain technologies ever imagined. No bulky umbrellas, no worries about gusts flipping them inside out, and you could even adjust the size of your personal dry dome. Sounds amazing, but that's only the idealized version of the story. Once you start crunching the numbers, enormous problems appear right away. The massive amount of energy required to vaporize water, the near perfect precision needed to hit each tiny droplet hurtling down at high speed, and the risk of turning your surroundings into a giant steam room. In other words, to make a laser umbrella real, we'd have to step deep into the realm of science, where numbers have a way of shattering even the brightest dreams. Let's talk about energy first. To vaporize just 1 liter of water, you'd need about 2.6 megajoules, roughly the same as running a high-powered hairdryer continuously for nearly an hour. Sounds costly already, but remember, a typical rain shower can dump millions of liters of water per square kilometer every hour. If you only wanted to keep 1 square meter above your head dry, your laser would have to consume about 9 kilowatts of power. That's nearly 10 times the amount of solar energy the sun delivers to the same area. In other words, you'd need to carry around a miniature power plant just to stay dry. And that's only the energy for heating the water to the point of vaporization. In reality, water absorbs energy very efficiently. Only about 10% goes into heating, while the remaining 90% is required for the phase change from liquid to vapor. Meaning, you wouldn't just be shielding yourself from rain, you'd be standing in the middle of a rising column of hot steam, as if you were walking inside a giant steamer pot. So, before dreaming of a laser umbrella, you might want to think about what kind of battery pack could possibly power it, and whether you'd actually want to live inside a scalding cloud of vapor. Let's say you've solved the energy problem. The next issue, safety. A laser powerful enough to vaporize raindrops is also powerful enough to damage human eyes in an instant. If someone accidentally walked through your laser umbrella, they could be blinded, suffer corneal burns, or even lose their vision permanently. Instead of being the dry hero striding through the storm, you'd be the nightmare of the entire street. And that's not all. Imagine millions of droplets being superheated into steam right above your head. The air around you would become thick with hot vapor, like carrying a portable sauna down the road. Your rainy stroll could quickly turn into a walk inside a scalding steam cloud, and nobody would want that. On top of that, if the laser ever missed its target, it could hit buildings, vehicles, or even an airplane flying overhead. A tool designed to fend off rain might end up being more dangerous than the storm you were trying to escape. In other words, the laser umbrella wouldn't just be impractical, it could turn you into a public hazard. Even if you were willing to accept the massive energy demands and the dangers of high-powered lasers, another thorny problem remains: how to hit every single raindrop. Rain doesn't fall slowly, drop by drop, like in a video game where you can take aim. To create just a 1 square meter dry dome, your system would need to fire hundreds, if not thousands, of laser pulses every second with pinpoint accuracy. That would require an insanely complex technological setup. Ultra high-speed cameras to capture the exact position of each raindrop in 3D space. Super fast AI to calculate their trajectories and decide which drops to hit. Adaptive optics to steer the laser beams to precise coordinates within mere milliseconds. It sounds far more like a missile defense system than a rain umbrella. And even if it worked flawlessly, you'd still be surrounded by the frantic hissing of thousands of raindrops being vaporized every second, a kind of technological symphony that nobody would want to listen to for long. In short, keeping yourself dry in the rain this way would require a setup as complex as a satellite control center. So if a laser umbrella is practically impossible, does that make the whole idea useless? Not at all. In fact, the very technologies behind it open the door to many fascinating applications. For example, instead of targeting raindrops, lasers could be used to de-ice airplane wings. In winter flights, ice buildup on wings is extremely dangerous. A high-powered laser beam could melt the ice instantly, keeping aircraft safe. Medical sterilization. Superheated steam could be harnessed to sterilize instruments without the need for bulky autoclaves. What sounds like a dangerous portable steamer on the street could be life-saving in a hospital. Meteorological research. The same laser camera systems designed to track raindrops could be repurposed to precisely measure rainfall speed, density, or even monitor airborne dust and pollutants. In other words, while the laser umbrella may forever remain a science fiction dream, the technologies around it help us better understand the atmosphere, enhance aviation safety, and support modern medicine. Sometimes, ideas that sound crazy at first turn out to be the sparks that push science forward. So in the end, the laser umbrella, an idea that sounds both cool and convenient, turns into a nightmare of energy, safety, and engineering when faced with reality. Perhaps it will forever belong to science fiction movies, where the protagonist strides through the rain beneath a shimmering, invisible dome. But science has a strange habit. Many of today's great technologies began as yesterday's ridiculous ideas. Who knows, maybe from the dream of a laser umbrella, researchers will one day discover new methods of climate control, create protective shields for astronauts, or invent medical devices we've never imagined. The final question is, if not lasers, what kind of future technology do you think could replace the old-fashioned umbrella we still carry today?